Okay, welcome everybody to week 14, day 2. There's no class on Friday, so don't be here or you'll be alone and sad. Friday is Veterans Day. So, what we're going to talk about today is we're going to continue our discussion of sets and maps in C++. We're going to show you guys a new variant of sets and maps called a multi-set and a multi-map. And we are going to do a little coding exercise together. And I'm just going to clear all this back out. And to show you the beginning here. So a student asked in the 12 o'clock section, is it possible to include all of the standard library? And the answer is yes. This is non-standard library. So there's no guarantee that this will exist on your system if you move it to a different platform. However, on a lot of platforms, there is something called bits.c++.h. If you do that, then you don't need to include anything else other than like readlib, which isn't part of the standard library. If you do that, then you get everything in the standard library. The trouble is it does kind of slow down your compile time a little bit. Like if we time g++ main.cc, you'll see there's a little bit of a lag on it. Not a lot. It's about like 1.7 seconds. Not too bad. For a file that, for all intents and purposes, is the entire, every single header file. So you don't need vector anymore. You don't need set anymore. You don't need that. You can just include bits to C++ and get everything. The trouble is, like, it does slow down your compile time a little bit if we do it without, with a time on it. You can see it adds about a second to your compile time, which, in the greater scheme of things, isn't the worst thing. It's a lot faster than you might think, right? Like you might think it's having to compile hundreds of thousands of lines of code. It doesn't. It's a precompiled library, but and yeah, you can copy your main from Pokemon 1 to Pokemon 2. Okay, so let's talk about sets and unordered sets. So a set either has something in it or it doesn't. And a set keeps everything in alphabetical order or numerical order if you have a set of integers, something like that. An unordered set has no order, but it's faster. So sets basically have order, login, insert, search, delete, and are sorted always. And unordered sets are faster. They are order 1. In other words, console lookup time. If you have a billion people in the unordered set, it can still find your item in a single operation, which is really cool. Insert, search, and delete. Not sorted, though. So you have to kind of decide, which one you want. If you want all your things always alphabetized or in numerical order or whatever, sets are the way to go. Unordered sets are faster, though. So if you don't need them all to be in alphabetical order all the time, unordered sets are better. And the reason why I'm teaching you this now instead of later is because hash tables, which is what an unordered set is typically considered a junior level data structure topic. And they're so useful that I just want to teach it to you guys in first semester computer science. I normally teach it in second semester. I've been moving hash tables, hash maps, earlier and earlier in the curriculum because they're so useful. So one thing we can use them for is for like seeing if a word has a repeated letter in it, right? It's like consider the word hello. Which letter of hello repeats? This is not a trick question. Good. What about Helen? Which letter in Helen repeats? E. Good. And so if you were to write a program, like let's say we're going to write a function, Boolean has a repeat in it. It's going to take a const string by reference s, and we're going to pass in a string like Helen or hello or Bob or something. And we want to return true or false. Does this string contain any letters that are the same? We could do it with like a doubly nested for loop, like for, and we pick the first letter, then scan through all the remaining ones. We pick the next letter, scan through all the remaining ones. Pick the next letter, scan through all the remaining ones. But that's like an order n squared algorithm, right? So that for if you've got like 1,000 letters in your string, you're going to do 1,000 times 1,000 operations, which is really slow. We can use a set to speed this up. So we could do this. We can make a set of characters named characters seen, and this will keep track of which letters we've seen before. So we're going to loop over for every character C in the string S. So for every character, we're going to say if characters seen contains C. So if we've seen that letter before, like we're reading through hello, the first L we have not, we pass L. Hey, have you seen this before? And it's like no, and we're like cool. So if it has seen it, then we return true, right? If it has not seen it, then we add it to the characters seen.insert C. Okay. And if we get through the whole thing without finding any duplicate letters, then we return false. Okay. So if we pass in Helen, the first time through the loop, C is H, right? It has character scene doesn't have anything in it, so it's not going to contain anything. So that's going to be false. So it's going to insert H into character scene. So we write down we have seen an H before, and then the next time through the character is an E. Have we seen a letter E before? Nope. So we add E to the list of character scene. Then we do the same for L. But then on the next E, have we seen E before? Yes, we have. So it returns true. There is a duplicate letter somewhere within this thing, and this is an order n algorithm, all right? Because you basically just have to go through all the characters, and as you go along, well, this is a set. We should probably make an unordered set. Okay. Unordered set, like this. And then it's an order n operation. So it goes from, like, if you had 1,000,000 letters in the string, actually it has 1,000,000 letters in the string, you know it has a repeat probably. Right? Because there's only like 52 letters. So, but let's say you have Unicode or something, right? So, but let's say you have 1,000,000 letters in the string. If you did a for loop where you say check the first letter and go through all the people looking for a duplicate, check the second letter, go through all the people looking for a duplicate, check the third letter, take all the people going through it for a duplicate, that would take 1,000,000 times 1,000,000 or 1,000,000,000,000 operations to do. This approach here can do it in 1,000,000 operations instead of 1,000,000,000. It's 1,000,000 times faster. So cool. Do you guys see the benefit here? And do you understand? This isn't like too hard to understand, right? There's just contains and insert, and there's erase, which we're not using, right? Like it's not order O24. What do you mean? What do you mean O24? Do you think there's 24 letters in English? Okay. There's 24 letters in the alphabet, really. Which letters did you get rid of? Which two do you hate? String S is equal to read. That's from Betancourt, the TI. Not. Okay. There's 26 Betancourt. Yeah, that's why rot 13 works, right? You add 13, you add 13. So remove the L. We don't like taking L's or double W's. A U is good enough. We don't need a W. Okay. All right. So we're going to read a string, and then we're going to simply see out bool alpha, so we get true or false instead of 1 or 0. Has a reading there, S. And there's more than 26 letters, right? These are chars. In ASCII, there's 128 values. But like I said, just assume we're working with Unicode, so there's effectively unlimited numbers of possible characters. We're not working with Unicode. We're working with ASCII. But yeah. Worst case scenario, if any string is greater than 128, you just return true. It's got a duplicate under the pigeonhole principle. Compile, run, type in hello, true. Type in hello, false. Type in hilo, false. Type in hello, false. Because lowercase and uppercase letters are not the same, right? So that was a capital L and a lowercase L. So do you guys see that? Does this algorithm kind of make sense to you? So what we do is we just basically, every time we read a letter from the string, we just say, hey, have we seen this guy before? Okay, we have. Return true. And if we haven't, then we just write it down. Hey, we've seen an H before. We've seen an E before. It's like you have a whiteboard. You just write down, okay, we've seen an H. We've seen an E. We've seen an L. And then you get another L. You're like, oh, he's already on there. That's a duplicate. Return. Do you guys understand the algorithm? Is this not too bad, I don't think, right? Okay. So now let's introduce the new thing. Let's introduce a multiset. So now instead of returning true or false, we're going to return how many duplicated characters there are. Okay? And I'm going to give you a buggy version of this, and I want you to fix it in lab time. Okay? So here is the hot newness. Multiset. Okay? Multiset. If you insert something in there, if you insert something in there, you can insert multiple times, and it keeps track of how many times you've inserted it. So after we've inserted everybody, let's just print out the multiset, and we'll take it from there. So we'll just return 0 for now. But we'll say for every character in the multiset called character scene. Let's see, and let's make this ordered. Let's make this ordered just so we get it in alphabetical order. It'll be easier to work with. We can make it unordered again. Easy. Like you can see how easy it is to switch back and forth between a set and an unordered set. You just delete the unordered part of it. And it's pretty easy. It's pretty straightforward. Okay. So we're going to do something called a multiset. And so if we had a set, every time you insert a duplicate, it just throws it away. When you insert it into a multiset, the duplicate gets inserted as well. And so you can have 5 copies of L in there. Okay. So for every letter in the character scene set, we will see out the letter, and we will see out characters scene dot count. How many times have we seen this character? Okay. And then it's going to just return false, whatever. I don't care. All right. So hello. We've seen an H once, an E once, an L twice, an L twice, an O one, and it's going to return false every time. So what I want from you guys is for you to fix this algorithm so it returns how many characters in here are in the string more than once. Okay? So let me run it again. Right now, if I type in Google it, right, Google's G and lowercase g are different, right? So that's fine. G, E, G, L, O is 2, O is 2. So what I want this function to be returning is 2. There's 2 letters in here that are duplicated. Now if I do something like zookeeper, this one should return 5. There's these 2 letters and these 3 letters, right? And so you can see here, we've counted there's 3 E's, there's 2 O's, all these 1s basically should get discarded. So it's your job to return 3 plus 2, essentially. And the way I would recommend doing this is by combining both a multi-set and a regular set. So doing something like this. So a set called character scene and a multi-set called character scene 2. Character scene 2. Okay. Now this seems kind of weird to you, but watch. When we were doing it this way, we got all of the duplicates back out, right? We got E 3 times. We got O twice. I don't want that. I just want E to appear once, and I want O to appear once. And so what I'm going to do is I'm going to use both a set and a multi-set. Big brain idea here. I'm going to say for every letter in the set, which will only appear once, I'm going to output how many times they appeared in the multi-set. So this will actually give us something very close to what you guys are going to need. So if I do zookeeper, you can see that this needs to be character scene 2. Thank you. Zookeeper. So you can see that we have an E appeared 3 times, a K appeared 1 time, and O appeared 2 times. so on and so forth. So, do you guys get why I'm doing this? Because the set will eliminate duplicates. So we don't have Z's and E's and O's appearing all these different times. We're going to get each letter once, but because we have a multi-set, we can just use that to grab the count of it. And so I'm using both a set and a multi-set. And what your job is to return the number here of letters in Zookeeper that appear elsewhere in the same string. So for Zookeeper, right, Zookeeper has 2 O's and 3 E's, right? So 5. So Zookeeper should return 5. Bookkeeper should return 1, 2, 3, 4, 5, 6, 7. Okay. Frank should return 0. So using this code here, I want you to fix this function. Right now the function is just returning 0 for everything. I want you to parse this code. I'll put it up on public copy main.cc, so you don't have to retype it all from scratch. Public main.cc, whatever, chp. All right, so what you guys are going to type is copy /public main.cc. You return how many letters are duplicated in this string. Okay. And so what you're going to type is you're going to type copy from public main.cc to your current directory. Make sure you're not in Pokemon or something, or it's going to override that. You know, go into some directory that doesn't have a main.cc in it, copy it in, and then I'll give you guys 10 minutes of lab time to work on this, okay? And then when we come back, I'll show you the answer. Do you guys all understand what your task is? So I've already set it up with the set, with the multi-set. Every time you insert into the set, it discards duplicates, so each letter only appears once when we're pulling it back out. But we also insert in the multi-set, which is going to count how many times each letter appears, and we're going to use those two in concert in a very clever way to be able to get how many duplicate letters are. Okay, begin. Okay, so yeah, that's pretty close. The let's see. So what you've done here is you've added all of the characters to the set and the multi-set. You're going through all the characters in the set, and then if the count is greater than 1, you add the count. But you still only return 0. So you did all this work, but oh, you did it. I see. You have call by reference, but you're still returning 0. Yeah, you should probably make that a void function then or something. I don't know. It's kind of weird, but yeah, I guess that works. It just doesn't make any sense as the thinking I had was that it would return the value, but yeah, sure. Okay, you got it. Your code's technically correct, even though it is kind of weird being an int function. Okay. Here we go. Int has repeat. So you're c-outing everything, which you can do. You can do that. I'd probably turn it off after you get it to work. So if the count's greater than 1, count is equal to count plus characters seen to dot count. Yeah, so that's also, you can also use plus equals instead of equals and count plus, but equivalent. Yeah, so this is the correct code. This is basically what I was expecting. I would probably comment out the cout once you get it working, but it's useful for debugging stuff. Another one here. For every character, if the count's greater than 1, you add to the sum. Yeah, that's perfect. That's great implementation there. Okay, and then so we only had 4 students. Here we go. I'm here and no idea what to do. 5, 6, 7, 8 people. All right. Here has an error. It's fine if you don't finish. Return bool alpha. You cannot return bool alpha. That is something that it's an IO manipulator is technically what it's called. If you do a cout double left arrow bool alpha, then the Boolean that follows it isn't going to come out as a 0 or 1. It's going to come out as true or false. So, yeah, that doesn't, it won't even compile if you do that. All right. I don't know if this is 100% wrong. Character scene count. Let's see what's going on here. So you're adding together. C doesn't even exist there, I don't think. I don't think this code's going to compile. Because C isn't even a variable in the scope. Right? Because C exists between here and here. It exists between here and here. But there is no C here. So, yeah, this code won't compile. And so this code here is doing something different from what was asked for, but it's kind of interesting. So let's take a look here. So we got a string passed in. We add everybody to the set, to the multi-set. For everybody in the set, we're going to print it out. This is all the code I gave you, and it's count, and then you're just adding to the count. So what you're doing here is you're just returning how many unique letters are in the string, which is not the question, right? So we probably even shouldn't count. We shouldn't call this has repeat. It should be like count repeat or something like that. So what you're doing is essentially returning like character scene dot size. Like you're doing a more roundabout way of just returning the size of character scene. And so that'll tell you how many unique characters you have in the string. So if we did it this way, then it's an interesting algorithm. It's wrong, but it's interesting, right? And so if we type in hello, it's going to give us 4, right? Because there's 4 unique letters in there. And if we type in Bob, the answer is 3, because that's capital B, not a lowercase b. If we type in lowercase Bob, we get 2, right? So interesting algorithm. Let's see what else. Anyone else? Okay. So what we want is this. So we want to have int count. And so for every character, int x. So x is how many times that letter has appeared in bookkeeper or whatever. If we're on the letter O, bookkeeper has appeared twice, and E has appeared 3 times, that kind of stuff. So what we're going to do is we're just going to say if x is greater than 1, then count plus equals x, and return count. Okay. So for any letter that has a duplicate in it, that's what we're saying there. That's how many times that letter has appeared. So we're going to go through all the A's, the B's, the C's, and if any of them have appeared more than once in the string, then we add how many times it appeared to our return value, and then we return it when we're done. And so yeah, so sometimes you have to make a variable. That's just the way that computer science is. So bookkeeper, it's like something from Mario. They're the person who keeps track of the booze, right? The little ghosts. There we go, bookkeeper. So we got 2 there, and 3 E's. So total of 7 duplicated characters. So we got 5 letters there that are duplicates, so on and so forth. So what I'd like for you guys to do next, now that you've got this function down, do you guys kind of understand multi-set versus set now? Like, you can insert things multiple times into a multi-set, and you can count how many times you've seen it. So it's basically the same thing as a set. If you only want them to appear once, then you can use both a set and a multi-set, kind of a clever way like this. Might be too clever. I don't know. I kind of like it. So now that you've got this function that can count how many unique letters there are, I want you to find out 2 things. 1, I'm going to post this code for you again. 1, what is the longest word in English without a duplicated letter. And 2, what English word has the most duplicated letters? And I will give you the code that will open up the dictionary. So the dictionary, locate dict, pipe through grep words. There it is. Boom, user share dict words. I never remember where it is. I actually just do that every time. Locate is a command that will find files on your system. So let's see here. I have string ends, shift insert there. So we're going to open up the dictionary. If there's a problem opening up the dictionary, we'll just quit without an error message, because who cares? This is just an in-class exercise. And so, vector of strings called English. This is going to be, we'll hold every word in English. So I'll just use my read library to make this fast. While ends, English dot push back read from the file. Boom, boom. Okay, so this is going to read. Did I forget something? Vector of strings. Vector of string. So we have a vector of a whole bunch of starts empty, and then what we're going to do is we're going to read one word from the English language, English dictionary, push it into the vector, read the next word, push into the vector, and we'll keep doing that until an end of file is read and pushed into the vector. So we need to drop the last person. English dot pop back is kind of a hackish thing, but the OF, because we're not, normally you read and you say if the file's still valid, then push it. I'm just doing a one-line read from a file, dump it into a vector, but then the last element in this vector is going to be duplicated if we don't do that. Here, let me show you what it'll look like if we don't do that. So for every font string by reference S in English, so for every word in English, see out the word. So that's going to dump the entire English dictionary to the screen, and it seems like it worked fine actually. Etudes. Wait, did it? No. See that? Yeah, we got that blank line there, right? So open it back up and yeah, drop the EOF basically. Do it again. Run, and you can see there's no EOF character there. Okay. Do apostrophes and stuff count? I guess. Yeah, I'm not uppercaseifying anything. I'm not lowercaseifying anything. I'm not stripping out things that have apostrophes. I don't care. Those are letters as far as you don't care. You got 20 minutes basically to do this. So, so given this, so this vector here called English, your task, right? Use the count repeat function and the vector of strings called English to find out one, yeah, D2D, P. Right arrow 2, right arrow DD. And there you go. Okay. So copy main.cc up into public CHP. And there you go. So if you guys want to copy this, copy from public main.cc into your local directory and call it bob.cc. I don't care what you call it. Or you can rename it anything you want, or you can leave it named main.cc. I don't care. There you go. There's the file. You got 20 minutes. Given this code, given the entire English language in that vector, given a function that can tell you how many repeated letters there are in a word, write code that will give you the longest English word that doesn't have a duplicate, and give me the English word that has the most duplicates in it. Okay? You can find like kind of the minimum duplicates with the maximum length, and the maximum duplicates are the two you need. And you could probably do this with just like one for loop. So you got 18 minutes. Begin. All right, let's do this. So we've got all the words in English. We can drop that and simply go through the English language, go through English, right? And we can have, let's just do number one first, the longest word without a duplicated letter. Okay, so int max length equals 0, string max. Okay, so if it's a name of a function, or name of a function is count repeat. Okay, so if count repeat s is greater than is equal to 0, sorry. So if we found a word that has no repeated letters in it, okay, now we have to see if this is the biggest one, right? So when we start off, our biggest one's 0, but maybe we've gone along and the biggest one we found before was 5. We need to see if the this new string here that has no duplicated letters in it is bigger than the biggest one we've ever seen. And if it is, that's now the biggest one we've ever seen. So if the count repeat is 0 and its length, s.length, is greater than max length. So if it has no duplicates and its length is bigger than the biggest one we've ever seen, then the biggest one we've ever seen is that string, and max length is equal to s.length. And then as it goes along, if it ever finds a new person with a longer string that's bigger than the one we've ever seen before, then it displaces it and goes on and on and on until it gets to the end, at which point it will have the longest string with no duplicates in it. So if we cout max, it should be good. Okay, so G++ and run and ambidextrously. Boom, there we go. So that is the longest word in the English language that does not have any duplicate characters in it. But bam. Okay, so that's like a temp. Yeah, you can call it a temp if you want. Except I'm going to have another temp in a second, so I'm going to have one called max and one called min. I don't know. Max 2. Variable names are hard, okay? They're hard. Okay. So that is the longest word without a duplicated letter. So which one has the most duplicated letters? So let's call this guy max length 0 and dupe length. And we're gonna have max and we're gonna have dupe. I don't know. You gotta be initialized to 0 or bad things happen. Okay. So if we have okay, so count repeat s. Okay. So if count repeat s, we probably should pull that out into a variable int repeat r, I don't know, equals count repeat s. Just turn this into an R. I don't know. It's not a great variable name. That way we don't have to call the function twice. All right. You don't want to call a function twice if you don't have to, so we're going to hoist it kind of out of it. We're just going to save the result of this, and we need a semicolon there, of course. All right. So if we have a number of repeats that are greater than the most number of repeats we've seen before, then dupe is our new winner. Dupe is the new this guy is now the biggest person we've seen duplicate letters in, and dupe length is equal to r. Okay, I think that should do that too. And so that would be dupe. So if we find somebody that has more duplicate letters than the most duplicate letters we've seen so far, then that is the new person with the most duplicate letters, and we write it down and write down how many duplicate letters it has. And so this is a standard max or min searching kind of thing where you loop through an entire vector, and you have like your king of the hill. The king of the hill is bookkeeping, but then bookkeeping gets knocked off the hill by zookeepers with 5 S's. I don't know. And then somebody else comes along and knocks them off. Every time you find a word that has a bigger number of duplicate letters in it, we kick the old king of the hill off, and a new king is crowned until they get kicked off as well. And electroencephalograph is the English letter that has the most duplicate letters in it. So we've got ambidextrously and electroencephalograph. And so that is basically class for today. I hope you guys can see the use of set and multiset. And if we want the code to go faster, which we do, we can do unordered set and unordered multiset. That will probably actually let's benchmark it. Okay, so G++, you time it, time a.out. And so the code right now is running in 0.138 seconds. Let's try it again with a unordered set and an unordered set and unordered multiset. So we're just gonna look just like that. Takes no more coding than just that. It switches out a lot of things under the hood, and here we go. So it runs slower. Okay, now it runs faster. Great. I should have run it multiple times. Huh? Minimum time is 0.111. Okay. All right. So let's switch it back. Go set and see. I mean, on a problem size this small, it's probably not going to make much of a difference because login is actually really fast. Okay. So time. Yeah, so the fastest this guy came in is 0.125. So the fastest the hash table did was about 10% faster. Whoop-de-doo. Who cares? Right? I mean, the difference in speed is basically within the margin of error on the runtimes anyway. So who cares? A set and a multi-set are both plenty fast. Unordered is going to give you better performance. So I'd probably leave it like that. Overall. And yeah, so Pokemon Part 2 is going to be due on Monday. You probably should be using hash tables, these unordered sets or things like that, unordered maps on it. You don't have to. It's not necessary, but it will help. And then it will definitely help you next Monday. Next Monday, we're going to do a coding competition. So make sure that you guys show up live for class for that. And only people that know unordered sets and multi-sets can win, because it will be your first assignment that is actually going to be testing your code execution speed. Okay, so there's both the coding speed, how quickly it takes you to write code, but then there's also the coding running speed, which also matters. So I try to optimize both. I both try to optimize my time so that I don't have to type very much and I can type quickly, get the code done and prototype it and debug it quickly. That's a very important thing to me. But also, at the end of the day, I want the code to be able to run quickly, compile quickly, run quickly, generate results quickly as well. So, is the way you did it good too. Let's pull up your thing. Scroll up. Okay. All right. Pull it up over here. All right. So that was fine. Yeah, you can do it that way. The only downside to doing it this way is you're going to be constantly recomputing the length of most word over and over again. So, like, let's say some of your words are like 1,000 letters long. You then look at the next word in English has. You then count how many repeats are in 1,000 letters, and then you go to his, and then it counts through 1,000 letters. You go to it, and then it counts through 1,000 letters. So that's why I put that into a variable instead of constantly recalling the function. It's possible the optimizer would be able to see through that and hoist it out so it doesn't get run every time as part of your normal thing, but it might not. I'd have to actually look at Godbolt on that and see if it's actually capable of pulling that out, because otherwise your code's going to run significantly slower. If can't repeat, s equals 0, and size is greater than long word dot size, long word equals s. Yeah, but I mean your code is fine. Like the code is great. I just pulled I put these two things here into variables so that it doesn't have to recompute it every word. But that's just an optimization. It doesn't have anything to do with correctness. It looks fine to me. So in fact, let's time your code. Where is your code actually? Main. Okay. All right. And if you're wondering what the backslash there does, that turns off the alias. So I have an alias set up for G++ for you that does different things. And I am disabling all these things because these things slow down execution speed. They increase safety, but they slow down execution speed. So I'm basically running it stock G++, optimizer turned on, and then we will time a.out, and your code is running in 0.5 seconds, right? So your code's running 4-ish times slower than mine. So in the greater scheme of things, who cares? Like if your whole thing was just like, tell me what the word is, you only run this one time. There you go. There's the longest word with no duplicates. There's the most duplicates. You're done. You don't need to run this 100 times a second, so who cares? If it's 0.1 seconds, 0.4 seconds, nobody cares. You run it once. But if this is code that's going to be running all the time, then yeah, that's why in C++ we care about things like call by value versus call by reference, things like that. You can end up having your code run 4 times slower by accident, right? Just you can see that the optimizer was not able to optimize that out. So even though it's being passed as a const, yeah, it didn't see through that. So your code is slower as a result. Okay, does anyone still need a group? Okay, so I'm going to stop the recording here, and then I'll group up anyone else who is missing a group for Pokemon Part 2.